at home, your job is to write down observations that could potentially help figure out what's going on in this demonstration. You may not leave here or end watching the video today and know exactly what's happening, but by taking good observations and jotting the things down we see, we might get closer, and later on we might not have enough, or we might have enough data where we can actually form our own conclusion or explanation of what's going on. All right, so right now you're probably already taking observations, right? What do you notice so far?
Safety glasses.
I have safety glasses on. What else?
A lab coat.
I have a lab coat on, right? And then, you notice the cheetah print and all that stuff too. But just by doing that, those are two observations, and you probably did it without even thinking about it. You probably assumed or inferred something based upon those observations, right? Did you? By seeing me in goggles and a lab coat, what do you automatically assume?
They protect yourself.
Yes, sir. Yeah, it could be dangerous. I'm not dangerous, but I might be working with something that's dangerous, right? So anytime in science when we're using chemicals or we're using another substance that could potentially be harmful to my eyes or body or clothing or anything like that, I'll put this stuff on. Sometimes I'll even put gloves on. Today I'm not going to, okay? Because this stuff won't hurt if it gets on my skin. All right, so the first substance I'm going to use is something called isopropyl alcohol. Does anybody know what isopropyl alcohol is? Yes, sir, Robert. Rubbing alcohol. You've probably come into contact before with this, yeah?
Yeah.
Okay, where?
If you have a cut, you use it to clean it, or
Yeah, you could use it for that. I just got my flu shot the other day, and they kind of swab my arm first before they give you the shot with rubbing alcohol. This is to basically just make sure that no bacteria or germs get into the open wound, because they're puncturing through the skin, right? So rubbing alcohol, isopropyl alcohol, if you've experienced it before, what are some properties that you've observed about isopropyl alcohol? I mean, here it is. Is there anything about it in terms of looks that is shocking or different?
It looks like water.
It looks just like water. So what are some adjectives that you would use to describe?
Clear.
Tommy?
Clear.
Clear. It's transparent. Absolutely. What else? Anything else? Is that it? That's pretty much it. In terms of looks, go ahead. Oh, it's a liquid. Good. Yeah. It is a liquid. In its current state right now, it is a liquid. Good. All right, so I'm going to drop that here. This is isopropyl alcohol. There are some other things about it, though, with my other senses that I could observe. What would that be? Ethan?
Smell.
Smell is a big one, right? Now, in science, I would never recommend just sticking your nostrils right into something and taking a big old whiff. Instead, we do this thing called, you know what it's called? We do wafting. Yeah, some students a couple years ago, they would call it doing the waft, and they dance to it. It was interesting. No, I appreciate it. It was fun. So you waft. And when I smell it, it smells very strong. Alcohol has this very strong kind of chemical smell. Okay? Something to note. Oh, and there's one more thing. This is probably super important. I just poured it on the table. What do you notice?
It looks like we're at a hibachi grill.
It does kind of look like we're at a hibachi grill. Oh, you guys are funny. So, don't worry about the countertop. It's not going to hurt the countertop. It's all fireproof countertop. But this stuff's flammable, right? And anytime something's flammable, it'll tell me on the label, as far as storage, it says warning flammable, keep away from heat and spark, okay? That kind of stuff. And you can see it's flammable. It doesn't burn as hot as something like gasoline, but it does burn very efficiently because I can see where the ring used to be, and in the middle it's burning away cleanly. And as that flame dies down, the little puddle of it gets smaller and smaller and smaller. All right, now in this, I'm going to put a really important chemical. It's called dihydrogen monoxide. Anybody ever used this before? Dihydrogen monoxide? Nobody? I'll tell you what that means. Dihydrogen, think di, think two, right? So two hydrogen. And then monoxide. So mono means one, oxide, oxygen. So there you go.
Why don't you just call it water?
Why don't I just call it water? Exactly. Because it's more fun to see the looks on your faces. So I'm gonna do 50 milliliters of each, and so I got water. Describe water. Write down properties of water. In your notes. What are some properties that you can think of? Observations. Does it have a taste? No. Does it have a smell?
Maybe.
No. If there's something in it, yeah, but then you're not smelling the water. It's odorless. Okay. Is it flammable? No. Thank goodness. Right? Okay. All right. So now I need some money. Anybody have a dollar bill? Evan has $10. All right. Let's do $10. I'm just gonna. Thanks, buddy. All right. So $10. Evan, did you need this for anything?
No.
Okay. Good. I'm just gonna put it in here. Okay. I'm not sure exactly what a dollar bill or $10 bill in this case is made out of, but I know it's not 100% paper, right? You know what it is? It's like a cloth, cotton kind of substance. That's so if you get it going through the dryer or whatever, it stays intact. It doesn't get all matted up or whatever. All right. Next thing I'm going to do is I'm going to light it on fire. Sorry. Thanks for your donation to science, Evan. All right. Okay, cool. I'm gonna hand this to Madison in the front row. Cools down really quickly. Cools down really quickly. So that's good. Doesn't get too hot. Is it how else would you describe the dollar bill at this point in time?
It's wet.
It's wet. Okay. If it's wet, it can be only one of two things, right? Or it could there. It can't be. What liquids are we working with? Water, you said? It could be water. Do we know for sure? We don't yet, but it could possibly be water because water is wet. All right. What other liquid could it possibly be that we're working with here today, Sarah? It could be the rubbing alcohol. Okay. What would you recommend I do based off of previous observations in order to determine if this is isopropyl alcohol in the dollar or water? Evan. I do the what? Do the waft. Yeah, anybody want to do the waft? You can do it. Look at everybody's so good. So I'll do it. I smell it very faintly, but it barely smells, which means probably most of what's on this is what?
Water.
Okay. We are going to still speculate that, but yeah, it's more than likely water. Okay. All right, we're going to stop right there.